Okay, today we're going to talk about different samples and surveys and their margin of error. So before we start, you need to know the difference between a population and a sample. A population is everybody in the group, whereas a sample is just part of that population. So for example, the school has a population, but this classroom is a sample of that population. Then there are different sample types, different ways to have a sample. There are four. One is a convenience sample. That means people are selected just at their convenience. So it's, do you want to do it like you're standing outside of a classroom and you're just asking people questions as they walk by? You're in the cafeteria just talking to people. It's just a convenient thing. Self-selected are when people actually volunteer to be a part of the sample. One of the most popular self-selected samples is the Publisher Clearinghouse drawing, where they send out mail to your home and say, do you want to participate? You send it back in and then they send you something and you keep sending stuff back and forth. It's all about you choosing to be a part of that sample. A systematic sample is when there's an order of a population in some type of way. Meaning if I get the school list of everybody in the school and I pick every 10th person to talk to. That's a systematic because there's an actual order to it. Random is that it's just completely random, pulling names out of a hat type sample. So with the sample, you have to be careful whether it's biased or not. As anything, biasness is opinion based. What might be biased to you might not be biased to someone else. As long as you can justify why you believe something is biased, you'll get this answer correctly. So in example 1, we have a newspaper that wants to find out what percent of the city's population favors a property tax increase to raise money for the local parks. What is the sampling method used for each situation, and does that sample have a biasness, and you should explain. So the first one is a newspaper article on the tax increase invites readers to express their opinion on a newspaper's website. This would be an example of self-selected because you choose from the newspaper article to go on the website and voice your opinion. Is it biased? No, because it doesn't have anything to do with the park. Like, there's no correlation between reading the newspaper and actually wanting to raise money for the park. So there's no biasness here. The next one is a reporter interviews people leaving the city's largest park. This is an example of a convenience survey because they're just standing there asking people as they walk by. Is it biased? Yes, it is biased because people that are leaving the park probably want to help improve the park. So they will probably be more in favor of raising taxes for it. The last one, a survey calls every 50th person from the phone book. This is systematic because it's every 50th listing and it does not have any bias, again, because the phone book calling people does not have anything to do with the park. Study methods. Once you have your sample, there are different ways to actually study that sample. One way is just to observe. You sit back, you measure things, and you just look at it. You're not affecting the study at all. The next one is a controlled experiment, and you might be more familiar with this in a science class. It's like you divide the sample into two groups. You feed one group a placebo, you feed the other group the actual medication, and see how it affects each group. So a control is the group that doesn't get the actual medicine, and the other group is your experimental group, and they get the actual medicine. When you compare the two, that is a type of study. A survey, you just ask people questions. And then you have a simulation, which is a way to model random events. And this is completely random. You will actually be learning more about simulations tomorrow after your quiz. Please remember, a poorly designed study can result in unreliable statistics, so you should always analyze a study's methods before you make general conclusions about that population. Meaning, you will be asked, could you use its results to make a general conclusion? Just like with the bias question, if you can justify your reasoning and it makes sense, then you won't get any points taken off for this. So looking at example 2, which type of study method is described in each situation, and should the sample statistics be used to make a general population? Conclusion about the population. So this first one is about choosing two groups from 10 people. Over a period of 8 weeks, one group eats ice cream before going to sleep, the other does not. Volunteers wear the monitoring devices while sleeping, and researchers record their dream activity. Because you have 2 groups, this is a control experiment. And can you trust the results to make a general conclusion? No, you only have 10 people. The sample size is too small. There's no way to rely on 10 people to overall say, does ice cream affect your sleeping? Next, students in a class record the height of bean plants as they grow. This is observational. All you're doing is recording how high the beans have grown. The results could be used determining how many bean plants you have and what you're looking at. Because it's very general, you're okay. Then students from the council ask every 10th student in the lunch line if they like cafeteria food. Because they're asking questions, it's a survey. The results could be biased because they're in the cafeteria, so they probably like the lunch food. And could the results be used? Probably not, because all the people in the cafeteria probably like the food. So that's not good enough to make a general conclusion. Now, when designing a survey, you have to think about what type of questions would you ask to try and not have any biases. So 2008 Olympic Games, a U.S. swimmer won more medals than any other swimmer in history. What sampling method could you use to find the percent of students in your school who recognize the swimmer from a photograph, and what type of question is likely to yield this information? This type of question is 100% opinion-based. As long as you can justify what you're doing, you're okay. For example, you might have a convenience survey where you just stand out in the commons and ask questions with holding up a picture. The type of question you ask about this picture will be whether it's biased or not. You cannot say, is this picture Michael Phelps? That gives them the answer. Something general, more like, who is this person, is more acceptable. The same thing with the question about recognizing your governor. As long as you can justify it and be very general in your questioning, you're okay. Margin of error is a statistic expressing the amount of random sampling error. In anything, there is always an error. You never are perfect in your math. And with statistics, you can say 95% of the population believe this, but we all know that it might not be exactly 95%. It could be a little less, could be a little more. What margin of error does is help you find an interval of where the average is likely to be. So based on a sample size and a convenient confidence level that is desired. So we want to be 95% confident in everything that we do. That's a good number to do. What that means is the probability is 95% true that the population is within a range of values. And that's the margin of error formula that we're going to use. Margin of error, ME, equals 1.96 times the standard deviation over the square root of the sample space. Standard deviation you learned how to find in Math 1. You can use your calculator to find it now. The way you find standard deviation in your calculator is first entering your information in STAT and then hit enter for edit. So for example, let's say we're trying to find the standard deviation of your test grades. So say you make an 86, you make a 78, and then a 91, and then oops, you made a 62. So these are your 4 test grades for the 6 weeks. If you hit the STAT right, option number 1 says 1 variable statistics. Hit enter and then calculate them. It gets you a long list of things. The first thing is your average of your test grades. So you have an average of a 79.25. The second one, that E, is the summation. So this is all your scores added up. The third one is all your scores squared added up. I don't know what this one is. This one is your standard deviation. So the little O with a line on the top, that is your standard deviation, and it's 10.985 and some change. In your problems, it'll tell you what to round to. N is the same N. It is how big your sample size is. So there were 4 grades. So these are the 2 numbers that you will need to find margin of error. Sometimes you will also need the mean so that you can see how far off the margin of error actually is. So keep that in mind. Stat, enter, type in your numbers, stat over option 1, calculate it, mean, standard deviation, sample size. Those are the 3 things you need. So let's practice. Grocery store manager wanted to know the wait times for customers in the express line. So what he did was he chose random numbers, random people, and timed them. So here are those random numbers. Pause the video now and type in all of these numbers in your calculator in the stat edit window, L1, all of these. Now that you have put all of them in your stat window, run your diagnostics, your stat over 1, hit enter, and see what you get. You should have an average of 5.4 and a standard deviation of 1.8. Notice the problem says round to the nearest tenth of a minute. If you do not have these numbers, double check what's in your L1 list. Then it says at a 95% confidence level, what is the approximate margin of error? Round to the nearest tenth. You plug these numbers in your formula, and again, this is not correct. This should be, how many are there? 1, 2, 3, 4, 5, 6. By 5, this should be 30. So 1.96 times 1.8 divided by the square root of 30 is 0.64 or 0.6 minutes. Then it says, what's the confidence interval? So that's actually when you add and subtract 0.6 from your average. So that would be 5.4 minus 0.6, which is 4.8 to 6 minutes. So what that means is, on an average, a customer waits 4.8 to 6 minutes in line at the grocery store. And this is actual statistics that different businesses use to see exactly on average what's happening. So again, type this in L1, run your statistics, get your average, your standard deviation, and it tells you N is 30. Plug it in your formula. Add or subtract this to the average. So this came 5.4 minus 0.6 and 5.4 minus 0.6. Gave me these two numbers. And that means that the person waits on average between 4.8 and 6 minutes. Now, how is your exam going to ask these questions? Because your exam is full of all kinds of questions with this. The first one, from a class of 12 girls, 10 boys, the students are selected to serve on a school advisory panel. 4 different types of methods are given. Which one is the best? And explain the weakness of the others. The best one is C, placing the names in a hat and mixing them thoroughly and selecting 3 people because it's completely random. The explain the weakness of the others, again, this is opinion based. My opinion is you can't select the first 3 names on the class roll because that's not random. Only the people at the beginning of the alphabet would get picked. First 3 students who volunteer, most of the time, those that volunteer are always the same people that volunteer, so they can't be used. The last one, select the first 3 students who show up from class tomorrow, same type of thing. You usually get to class at the same time every day, so it would be the same exact people. It's not random. C is the random choice. Then a department store manager wants to run 2 advertisements and see which one's more effective. So what they're going to do, out of a sample of 100 people, they're going to pull 100 people from 5,300 and read them 2 different articles. Describe the method. That's completely up to you as to how they should go about it, whether it be convenient, sending something home, when they get the credit card, whatever. And then flipping a coin to see whether it's A or B. Because flipping a coin is equally likely, then this is a reasonable way to do the advertisement. All right, the next question, the best type of study to figure out who likes the college professor the most would be a survey. And our last is a margin of error problem. do it the same way we did before. We're